Hi everyone. So today we'll discuss about the BFS graph traversal algorithm. In my previous video, we have discussed about the DFS. So if you haven't watched that video, please check that video because these two are the most important part of the graph. And for every question in the graph, either you need to use the DFS or BFS. So you need to understand the concept behind these two traversal, how they are working and how to think about the problem and how to use DFS and BFS to solve the problem. All right. So we will discuss about the BFS now. What is the BFS? BFS stands for breadth first search. It is nothing but it is very similar to the level order traversal in the tree. Okay, so you will say, hey, why we are why we are learning it again? So only there is one difference between tree and graph is tree will never have a cycle. Okay, but in case of graph we can have a cycle as well. Okay, so let's say we'll apply the level or the traversal for the same problem. Okay, so what you will get, one second. So if you will apply the level or traversal for the same problem, first of all, you will traverse all the node at the level 1. So this is your level, okay, let's say 0. This is level 1. This is your level 2. Okay, you will print all the node which are at the level 0. First of all, you will print 1. Then you will jump to the next level. You will print all the node which are present at the level number 1. So you will print node 2 and node 3. Okay, then you will jump to the next level, which is nothing but level 2, and you will print all the nodes which are at the level number 2. So you will get 4, 5, and 6. Sorry for my handwriting, 7. Okay, so these four, this way, this is our level order traversal of the above tree. Okay, so the only difference between the tree and graph is that in case of graph, you can have the age like this also. Okay, you can have like this also. But in case of tree, you can always go from parent to child, but not from child to parent. But in case of graph, we can come from parent to child, we can go from child to parent, everything is possible. Okay, so in case of graph also, we need to understand the BFS. All right, it is slightly different from the level order traversal, but the top level concept is exactly same for both. So let us jump to the next part. So here, let me explain you with the help of an example. So let's say this is the graph we have. This graph has 5 nodes. Node 0 has age 1 and 3. And from node 1, we can go to node number 2. From 3, you can go to node number 2. And 4 is not connected to any other node. It's completely kind of disconnected graph. Okay. So you will, let's say you will pick any one node just to start with. So let's say here we are starting from the node number 0. So first of all, what you will do, you will traverse the node. So you will print the 0. All right. Then you will go to the next level. Next level means all the child or all the neighbors. In case of tree, we will call it child. In case of graph, we will call it neighbor. So all the neighbors of 0 are nothing but 1 and 3. So just print 1 and 3. All right. Then go to the one of these. Okay, just print all the neighbors of 1. 1 has neighbor 2. Just print it. Okay. Then jump to 3. Print all the neighbors of the 3. So you will print 2 again, right? In case of 3, you will print 2 again. But here, very important part is, in case of traversal, you need to print every node exactly once. So that's why here, instead of printing this 2, what we will do, for each node, we will keep a pointer. We will keep a visited array, which will store if this node is already visited, do not print it again. Do not traverse it again. So here we'll see, hey, 2 is already printed. So do not print from the 3. Okay, don't do this thing because 2 is already printed. Now you have printed 0, 1, 3 and 2 so far. Now you will go to 4 because 4 is not connected to anyone. So you will again start your logic from node number 4. So again, let's say level of 4 is, you can say 0 level. So just print the 4 in the last. So this is your order. First of all, you will print 0, you will print 1, 3, then you will print 2, then you will print 4. This is how the level order traversal of the graph will work, or BFS of the graph. Now let me just, so you can see 0, 1, 3 and 2, 4. Okay, so do not worry, let me explain you in detail in the next part. So here I have taken the same example. Now, this is just the explanation part, but when we talk about the actual code, how to write down the code. So you have seen in case of tree, we have used queue for the level order traversal. Here also we need to use the queue. Apart from queue, okay, very important is we need to maintain one visited array. Why we are doing that? Here we have discussed already. If you will not maintain it, you will print this node 2 times. Okay, this node we have seen, you will print 2 times here. So just to avoid that part, okay, we need to maintain one visited array, which is nothing but that you need to print each node only once. Now, what is the logic? Logic is very simple. Start from the any node. Let's say we are starting from 0, just insert 0 into the queue. When you are inserting the node into the queue, that time you can mark it as visited. So let me just mark the node 0 as visited. So we can say true, false, or we can mention some value 0 and 1. 0 means it is false, 1 means it is true. So when you have inserted node 0 into the queue, just update the visited as true for this node. Now what you will do, you need to pop this element from the queue. And you need to insert all the neighbors of 0 into the queue. So 0 has 2 neighbors, 1 and 3. Insert both into the queue, and along with that, you need to update the visited as true for both the nodes. So very simple. When you are inserting some node into the queue, that time you need to mark visited as true. Okay, so once you are deleting from here, you need to print here. Okay, just to get the BFS of the graph. Now you will delete this front node of the queue. Okay, now if you are deleting it, you need to print it, and you need to insert all the neighbors of 1. 1 has only one neighbor, which is nothing but 2. So you will insert 2, and along with insertion, you need to update the visited as the true. Now 1 has only one neighbor, which we have done. Now you will delete 3 from the queue. Once you are deleting, you need to print it first of all. After print, you need to find neighbors of 3, which is 2. Now, here you will not insert randomly. Before inserting into the queue, you need to check one condition. If this node is already visited, do not insert into the queue. So here you will see that 3 has 2 child. So you will not, okay. So here we will not insert 2 because it is already visited into the okay, because it is already visited, you can see from here. So that is fine. You will just print the 3. Now you will delete this 2. Okay, after deleting, you just need to print the 2 first of all, and find all the neighbors of 2. 2 is not having any neighbor, so don't do anything. Now this is done. Our queue is empty. Now again, you need to run a loop and check if there is any node which is not visited yet. Yes, 4 is not visited yet. So you will insert 4 into the queue, and you will mark the true. Okay. Then you will delete the 4 from the queue, insert into the, or print it. After print, just see just find out all the neighbors of node 4. If we have, just insert those into the queue. So since 4 doesn't have any neighbor, so no need to insert. And since our queue is empty, okay, queue has nothing now. So if queue is empty, then this is our final answer. Okay, so you can see 0 level. This is the first level. This is your second level. This is your third level. This is your fourth. Okay, this is not a level. It is kind of the different graph, or the part of the graph which is completely independent of the previous graph. Okay, but we need to traverse all the nodes. So this is our final order for the BFS. Now let me quickly explain you the algorithm or the pseudo code, how we will do that. So first of all, what we were doing, we were inserting the node into the queue. Okay, this line will insert, okay, into the queue. And along with the insertion, I was talking that you need to update the visited as the true. You can see here, okay. So here we are updating the visited as the true for the inserted node. Now you need to apply one condition. Apply while queue is not empty. Yes, queue is not empty. You need to delete the first element of the queue. Once you will delete this particular element, you need to print here. So here we are not having a step for print, but here you need to print. Let me note down here. I missed it. So you will print it. Okay. So this way you will print it. Now, after the print, what you will do, tell me? You need to find all the neighbors of the node. So you will find all the neighbors of the V. So we are running a loop just to find out all the neighbors of V, and you will check if it is not visited, insert into the queue and mark it as visited. Again, same logic. Okay. So we'll keep doing this thing until our queue is empty. Now, very important part. So when we are calling this function, okay, that time we need to run a loop just to make sure if we have any node which is not visited yet. Why? Just to cover this kind of graph also. Okay, that's why we need to run a loop. Now let me explain you with the help of one code. Do not worry about that. So here I am just explaining you with the help of C language. Okay, now here let me increase the size. So what we are doing, just to make it very simple, I am using the adjacency matrix representation of the graph. So let's say, and by default, I'm just taking 15 as the maximum number of nodes in the graph. You can take it, depends on the how many nodes your graph has. Okay, but here, since I'm using 4 or 5 nodes, so randomly I'm just giving the number which is greater than 4 or 5. Okay, now you need to take one queue, because in case of C language, we are not having predefined queue. In case of Java, C++, everything is predefined in the libraries. So here we need to define the logic of the queue in terms of array. So for this, there is already one video I have covered as part of the data structure for the beginner series. So you can check out that video. There we have discussed about the queue, how to insert into the queue, how to delete, means everything about the queue, how to implement the queue with the help of array data structure. Okay, so here also I will use the same logic. Now what you need to do, this is our main method. Okay, so first of all, we are marking all the node as not visited. So this value 0 means all the nodes are not visited yet. Then we will initialize our graph. By default, 0 means there is no edge between I to J. Okay, then we will actually insert the edge. So what we are doing, from node number 0, you can go to node number 1. So update it by 1. It means there is edge from 0 to 1. Okay, similarly for 0 to 4, 0 to 3, then 1 to 2, and 3 to 2. This is our graph. Now here what we are doing, we are just calling one BFS method with the source. Now what basis we are deciding the source? We'll just run the loop on all the nodes, and you need to call the BFS if any node is not visited. Okay, so if your visited of I is 0, just call the BFS or with the source as I. You will come inside this thing. What is the first thing you will do? First thing, you will insert element into the queue. So here we are inserting element into the queue, and after that you just need to update visited. Okay, so two things you need to do. While inserting, you need to mark visited as the true. Okay, and when you are deleting from the queue, you need to print the element just to get the BFS of the graph. So here we are deleting. Now we are applying condition. This is nothing but the condition just to check our queue is not empty in case of C language. Okay, and this time we are deleting the element from the queue. and first thing we need to print it. After print, so these two lines, okay, these two lines are nothing but just to delete element from the queue. And after delete, you need to print the element which you have deleted. And now you need to find all the neighbors of 10. So all the neighbors, which all the age which are coming from the temp node. Okay, and those should not be visited. Then you will insert them into the queue again. Okay, and you will update the visited as the true again. So this line will also be part of this insertion here. Okay, and after that, what we are doing is we are updating the visited, and this is just to, we are getting one size. It is not required here. You can delete it also. So let me delete it. Okay, it is not required. Fine. So what we are doing, insert the node into the queue and update the visited, apply the condition while queue is not empty, you need to delete element from the queue. After delete, you need to print the element and then find all the neighbors of the deleted node which are not visited. Then you need to just again insert those elements into the queue and apply the same logic. Okay, so let me quickly run it and show you the output. 1 second. So here, yeah. So this is what we got, 0, 1, 3, 4, 2. Okay, how we are getting it? Let me explain you. So from node number 0, we can go to 1, 4, and 3. So node number 0 is the level 1. So which we have printed. Then level 2 has 3 nodes, 1, 4, and 3. So we are printing 1, 3, 4. Okay, then we have from 1 we can go to 2, which is at the level number 3. So you need to print the 2 then, and from 3 to 2 also, since 2 is already printed, no need to print it again. And that's how we got our BFS for the graph. Okay, so this is the code which I have explained. I will add this code into the first comment of the video. Okay, so do not worry about the logic and how and what we are doing here. Now let me quickly explain you the Java code also. If you are not good in the C language, no worry about that. Let me quickly explain you with the help of Java. So this is our Java code. This is how we have declared a graph class, and our graph here we are using the adjacency list representation. Okay, so this is how we can do. It's very simple. In my previous video also we have discussed about these things. Okay, so if you are still not clear, let me know. In the next video I can explain you about this thing. All right, so here this is how we are inserting the age in the adjacency list. Okay, now let's jump to our main code. Here again we are doing the same logic. There is one boolean type visited array. By default all will be false, and we are running a loop. If any node is not visited, you need to call the BFS, okay, with the source. All right, so you will come to this one, you will insert into the queue. Along with that, you need to update the start, you need to update the visited as the true, you need to apply the condition while queue is not empty, delete the element from the queue. Just after delete, you need to print the element. We are printing here, then find all the neighbors of the deleted node. This way, along with that, you need to check if it is not visited already, then only you need to insert into the queue again. All right, so it's same logic, but here the only difference is we are using the queue from the library. Okay, we are not writing the queue in terms of array. Okay, that is the only difference. Everything, logic, concept, everything same. Okay, so you can take a screenshot if you want, or I will add this code also into the first comment or the second comment of the video. All right, now let us talk about the time complexity. It's very important. In case of C language, okay, we have discussed the approach with the help of adjacency matrix. Okay, we are taking one 2D matrix, and here what you are seeing one thing. So for every node, let's say for every node, you will come in this method, right? because then only you will print it. So for every node, you will come here, and for every node, you are running a loop. Okay. We are running a loop for every node just to find out the node which is not visited. Okay. So here for every node means how many nodes we have? We have n number of nodes. And for each node, you are running n number of loop. Okay. You are running a loop n number of times. So time complexity will be nothing but your n multiplied by n, which is nothing but your n square, where n is nothing but the number of vertices in the graph. Okay. Now, same time complexity we can improve with the help of your adjacency list. So in Java code, if you'll talk about that, here for every node, we are not running the loop n number of times. We are running the loop only as the number of times the current node has the edges or the neighbors. Okay. So if you will think about it, okay, it is nothing but for each node, you are running the loop as the degree. Okay, as the times the node has degree. So what I mean is, let me explain you. In my previous video, we have discussed about this thing for the DFS. So for node 1, you are run a loop as the number of times of the degree of the V1. Then for V2, okay, you will run a loop same as the degree of V2 and so on. So if you will divide it into two parts, so you will see all the nodes and summation of all the degree. All right, then it is nothing but the capital V, how many vertices in the graph we have. And this, so this line will represent the capital E, which is number of edge present in the graph. So time complexity in case of adjacency list will be of V plus E, where V is the number of node, E is the number of edge in the graph. But in case of adjacency list, we have seen time complexity will be V square. Okay, or here we are using n, so it will be n square. All right, I hope it is clear, everyone. So if you feel something is not clear, feel free to comment out. I will be happy to help you in my next video. All right. Thank you, everyone. If you like my content, please like, share, subscribe.